Alright, so if you're watching this video, it's because you were in the group that was cathode ray, and you need to be ready in class tomorrow to explain to the girls what's the cathode ray, okay? So let me just go over it. The cathode ray was the experiment of a scientist. His name was J.J. Thomson. Alright, and he did an experiment called the cathode ray experiment. We need to know that. Alright, the cathode ray experiment was done using a cathode ray tube. Right, and if you look here in the picture down here, this is a cathode ray tube. See this tube here? This is a cathode ray tube. And the cathode ray tube, what happened was, I'm going to scroll down, okay? What happened in the cathode ray was, this is the cathode ray tube, is another picture. And you can see here that we have a cathode and we have an anode. Do you see that? Cathode and anode. Now the cathode, it has negative charge. It's a negatively charged plate. And the anode, you can see on the picture that the anode is what? It's a positively charged plate, okay? So we go from the negative to the positive. Now, if I have a battery, here's the power supply. If I have a battery, the current will move like this, okay? And when it gets to the cathode, which is negative, okay, it will travel in the tube to the positive. It will go from the negative to the positive. So it's like this. It's going like this, from the negative to the positive. Okay, this is the cathode ray. So the first thing that he discovered was that the cathode ray, it travels in a straight line. And you can see that in this picture here. Do you see that? The cathode ray here is traveling in a straight line. You see the straight line? You see the straight line here? It's traveling in a straight line. Okay, that's very important. It's traveling in a straight line. So that's number one. He discovered the cathode ray travels in a straight line. All right, and let's go back down to our picture here. Oops, some things they moved. Oops. All right, so the cathode ray travels in a straight line, but in this picture, it looks like this, that is not in a straight line, because here I have an electric field. Do you see this? Electric field. This is an electric field. Electric field, it means I have plus and minus. So here's positive and minus plate. So if I have the cathode ray traveling in a straight line, what he noticed was the line went up. It went to the positive. Now you know that positive and negative, they attract. So this made him to conclude that the cathode ray has a negative charge. So this is something that you need to know it. So you see this cathode ray here, this cathode ray, and it says it on the picture, it has a negative charge. Okay, so we said two things. Number one, the cathode ray travels in a straight line, and I showed it to you in the picture up here. The cathode ray travels in a straight line. Okay, you can see it in this picture. Oops. All right, and then down here, I told you the cathode ray has negative charge. Okay, so we've discussed two things. Okay, so I'm going to highlight it here in the notes. It says it travels in a straight line and it has a negative charge. Okay, now the third thing that he said here, that it's independent of the composition of the material from which it originates. Now, because the negative is coming out of the cathode, he thought that the cathode ray was the cathode, but it's not. It's something else. It's from the electricity, and later he discovered it to be the electron. Now, J.J. Thomson, we want to know that he discovered the charge to mass ratio of the cathode ray particles, a charge to mass ratio. You want to know that. And he measured the value to be this much coulombs per gram. That's the charge to mass ratio. All right. Now, if you look down here, I think I have one more thing I want to mention, that here's the cathode ray again. If you look in this picture, here's the cathode ray again. Do you see it's red? And this is actually a magnet. Okay, this is a magnet. So he also said that if you bring a magnet, the cathode ray will move. Okay, so the cathode ray, it's traveling straight, but if you bring a magnet, it will not be straight. It will move. And if you bring electric field, it will not be straight. It will move. Okay, so you need to be able to explain this to the class tomorrow. Okay, make sure you can discuss J.J. Thomson's experiment, the cathode ray tube, and you can go over what were his conclusions.